Hello, everybody. This is Pete Mattaliano, and today we're going to talk about t-tests, and we're going to demonstrate for you single sample t-test and through SPSS and independent t-test. Before we begin, though, I think it's important to talk about some prerequisite skills and understandings. Given that you have some knowledge about statistics, I'm not going to talk too heavily about definitions, but more brief understandings of topics. So first we begin with normal distribution. And what's important about normal distribution, again, is that there will be a mean, there will be standard deviation. The standard deviation in a normal distribution has given probabilities, and what's most important is that from the mean, they are equal one side to the other. Probability or chance, the percentage that something would happen. So again, the easiest example would be if you have a coin and you were to flip it, what would be the percentage that it would land on, either tails or heads? The mean, of course, is an average. What's important for this task is understanding that when you're talking about the sample average, you're talking about X bar. When you're talking about the population average, it would be represented as mu, which is a Greek symbol. Standard deviation, again, for a normal or a bell curve, it is the dispersion of a data point from the mean. And again, the probability of something falls in certain areas are represented by the following percentages. Regarding standard deviation, when it's referred to in a sample, it would be referred to as S. When it's the standard deviation of a population, it would be referred to as sigma. Degrees of freedom have various definitions in terms of the way a number can move. What's important for a single sample t-test is the degree of freedom represents the number of the sample minus 1. So what a t-test tells you is given a critical value, which is you'll find out from a t-table, whether or not to accept or reject the null hypothesis. That's what the t-test will tell you. It will help you to understand whether or not the given mean that you have should be accepted or rejected. So the way that you figure out the critical value is using a t-table. And what you have to know is whether you're looking for a one-tail or a two-tail t-table and what alpha you're going to use, which is your percentage. So if we use 0.05, we're saying with 95%, and let's just say we had a sample size of 30, you would follow down to your degree of freedom, which is 1 minus 30, which is 29, and you follow the table to the number of 2.045. So if your t is greater than 2.045, you would be rejecting the null hypothesis. Okay, so samples, t-test, there's 3 different types. There's the independent sample t-test, which in this case you have, the example would be a drug company is trying to test out their new pill, and they want to know the effectiveness of the pill. They do that by measuring the cholesterol of a group of people versus the cholesterol of a group of another people. That would be an independent sample t-test. A paired sample t-test would be, let's say you want to measure the effects of alcohol consumption on a group of workers. So what you would do is you would um, measure their effectiveness before they had a drink, and then the same group would be measured after they had a drink. So in this case, the variable would be time and not the group. And a single sample t-test, which is the example we're going to follow, will be you're given a mean, and then you're going to test your sample against that mean to determine whether or not you would reject or accept that mean or the variable against that mean. So here is the formula for a t-test with a single sample. And again, most of the prerequisite terms were discussed because of this, because in order to calculate t, you need to know the degrees of freedom, the sample mean, the sample size, the population mean, the sample standard deviation, and the standard error of the sample mean. You also need to research the problem or question and establish a null hypothesis and an alternate hypothesis. So T tells you in different cases whether the samples are reliably different or if it's by chance that there was a difference. Measures variance between groups, whether or not to reject or not to reject the null hypothesis. That's what a t-value and a t-test will tell you. So here's an example. So given the formula from before, what we get from this is that so when you calculate the sample mean minus the mean over the standard deviation divided by the square root of the number, you would get 50 over 3.65, which would give you a t of 13.69. Given the sample before, the critical value of t was 2.04. So if we were to look at that distribution, if our critical value was 2.04, our null hypothesis said that, and with a t-value of 13, we would have to reject the null hypothesis. So we would be saying that the mean of our sample definitely exceeds the mean, therefore nullifying the null hypothesis, which basically would be interpreted to say that the drug that we're testing has to have a positive effect on IQ for the mean of the sample to exceed the mean of what is known. So another example, which I will use SPSS to solve, will look something like this, which this is an independent t-test where you actually have multiple sets of variables because you have two different groups that you're comparing. In this case, you have class A and class B. Then you have means of each class. you have standard deviations of each class, and given the information, you're going to see if the means are reliably different from each other.